Okay, so let me start this by saying if anybody has any questions about yesterday's homework, definitely send me a remind message. I'm going to bring my textbook home so I can look at whatever questions you have on whatever numbers, and I can do them out on a separate sheet of paper and just send an image out back to you, if that's helpful. I should be here tomorrow. That's the plan anyway. So regardless of my kid's situation, I will be here tomorrow, so we can answer some questions then too. But I would prefer if you sent me some of your questions ahead of time. If this video finishes early, you can also, talk with each other. But you're going to get it, again, I've showed it to you already, a giant reference sheet with a whole bunch of formulas for this chapter. And I would normally hand that to you today, but I'll just give it to you tomorrow because the 4 formulas that you need are right here on the top. These are the sum and difference formulas. So what's interesting is up until this point you thought you can only find the sine, cosine, and tangent of 0, 30, 45, 60, and 90 degree angles without a calculator. But the truth is you actually can find more than just that if you also have these formulas. So I didn't come up with these formulas. Some genius figured them out, but we're certainly going to use them. So for the cosine of 15 degrees isn't one of our memorized values, but we can construct 15 into something plus something or something minus something that we do know. So sticking with 30s and 45s and 60s and 90s, I can change 15 to 45 minus 30. That's an okay replacement for 15. And then I do know the cosines and sines of 45 and 30 degree angles, which is the benefit here. So if I look up here, I switched it into, and I used subtraction. So I'm going to use equation 2. And it's going to be the cosine of alpha, cosine of beta. So alpha is just the first angle, so in our case that's 45. And beta is the second angle from our subtraction, so in our case 30. So that's going to be cosine of our 45 times the cosine of our 30 plus the sine of our 45 times the sine of our 30. And then using our values, we will make that root 2 over 2. Cosine of 30 is root 3 over 2 plus sine of 45, root 2 over 2. And the sine of 30, 1/2. So you can see even more so why those memorized values are critical. So we get root 6 over 4 plus root 2 over 4. We already have a common denominator, so we can just really just bring these two fractions together, and that's the exact value of the cosine of 15. I'm in degrees here, so I'm going to make sure my mode is in degrees, which it is. If I look at the cosine of 15, I get this number. What I just found was that supposedly is the same thing as root 6 plus root 2 divided by 4. And you can verify that they're exactly the same. So number 2 actually gives us one of these versions and is asking us to go backwards. So cosine, cosine plus sine, sine. Cosine, cosine plus sine, sine. That's the difference formula. So what's in your alpha position is 80. So going backwards, minus what's in your beta position is 20, which becomes cosine of 60, which is 1/2. So you may be asked to recognize something like that and use a formula backwards. Okay, here we have 7 pi over 12. Okay, so this is in radians, and we got to think a little bit about radians and what we know. We know pi's over 4s, pi's over 3s, pi's over 2s, and pi's over 6s. So at first I'm going to keep it pi over 12 and break up 7 pi into, and you can play around with it. You could do 2 pi and 5 pi. But unfortunately, we don't know what 5 pi over 12 is. 3 pi and 4 pi, that works because 3 pi over 12 and 4 pi over 12 both reduce to something useful, pi over 4 and pi over 3, and those are memorized values that we know. So this is equation 3, sine plus plus. Our alpha is 3 pi over 12. We're going to make that pi over 4. And our beta is 4 pi over 12. We're going to make that pi over 3. And then we're just going to plug into the formula. Zoom out a little bit so it's all on the same page. So that's sine of pi over 4 times cosine of pi over 3. Right here. Plus cosine of our pi over 4 times sine of our pi over 3. And then we just evaluate and simplify. Sine of pi over 4, root 2 over 2. Cosine of pi over 3, 1/2. Cosine of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. So we're going to get root 2 over 4 plus root 6 over 4, and it just coincidentally happens to be the exact same value as that first one. Okay. So on number 4, sine of 5 pi over 12, we'll take a minute and think about how you could break up 5 pi over 12. I think 2 pi over 12 and 3 pi over 12 would certainly work because we have pi over 6 and pi over 4. So again, we'd use the same sign of addition. There are multiple ways as well. So I thought of this. We could do 9 pi over 12 minus 4 pi over 12. And that would be the same. This would be 3 pi over 4, and this would be pi over 3. Pi over 3 is great. I'm not saying you can't do it, because you definitely can, but if you were to do something like 3 pi over 4, just be a little bit careful, because that's not in your first quadrant anymore. That's not really your reference angle values. So you'd have to, if you were coming up with all these values, you'd have to be a little bit more cognizant of what quadrant you're in and whether it's a positive or negative in that quadrant. So as much as you can, stick with angles that are going to reduce to first quadrant angles so that everything's just positive and you don't have to worry about it. So you could, with any extra time, I would just go through this one in practice, and then you can use your calculator checking like we did on that last problem to kind of verify your answer. And then, of course, the proofs are going to continue. And in this particular example, immediately when we have this cosine alpha minus beta, we're going to want to go up and substitute out this here. So that's going to become, and I'll move it up here. That's going to be cosine alpha cosine beta plus sine alpha sine beta all over sine alpha cosine beta. Okay, so on that side of things, there's certainly nothing to factor out. What we could do, because we have a binomial divided by a monomial, we could split up the fraction. In other words, cosine alpha cosine beta over your denominator plus the second piece of the binomial over the denominator. So it's almost like rather than getting common denominators and adding fractions, we're actually separating this one. And the reason I'm doing that is because there's pieces that could cancel. So I split it up into two fractions. Now within this single fraction, your cosine betas are gone. Within this single fraction, your sine alphas are gone. So this is just cosine alpha over sine, which is cotangent alpha, plus sine over cosine, both of beta, is just tangent of beta. And we're done without touching the right-hand side. So that, I don't know, I'm sure it came up maybe last night in your homework, that technique, whether or not people thought to do it or not, because I don't believe it came up in our notes, where we split up a fraction that's already unified as a single fraction, but there's a binomial up top over a monomial, so we can split it up into two separate fractions and get things to simplify that way. Alright, so this next example, we're going to have apparently something like this on our homework, where suppose the sine of alpha equals 12 over, I think that's a 13, although I'm going to quickly. For a quadrant 2 angle, draw it. Immediately draw it. Quadrant 2 angle. And my alpha would be here. And as soon as I can read my own writing, I will let you know how to label the opposite. Definitely 12. Opposite is 12. I can read that. It's the hypotenuse I'm worried about. I can't read it. Yeah, 12 over 13 is where I got that. So 12 opposite over hypotenuse is 13. And then, of course, complete your triangle, because Pythagorean triples are at work here, of 5, 12, 13, but since this is negative, this is negative 5. And sine beta for a quadrant 1 angle, beta, there's our beta. Sine is opposite, 3 over hypotenuse, 5. Pythagorean triple tells us that this is 4. So find the exact values for cosine of alpha. So this is old stuff. So in alpha, we would go adjacent over hypotenuse, negative 5/13. Cosine of beta, we would go adjacent 4 over hypotenuse, 4/5. And then they're going to give us this cosine alpha plus beta. So grabbing your formula from the front side, it's cosine alpha cosine beta minus sine alpha sine beta, so that's right in front of us. So the cosine alpha, negative 5/13. Just plugging in and simplifying. Cosine beta, 4/5. Minus sine of alpha, they gave us 12/13. Sine of beta, 3/5. So we get negative 20 over 65 minus 36 over 65, negative 56 over 65. And then D is going to be this, a similar problem, just different formula. Sine of alpha plus beta, stealing that formula off the front. Sine alpha cosine beta plus cosine alpha sine beta. So sine alpha given, 12/13. Times cosine beta, 4/5, plus cosine alpha, negative 5/13, times sine beta, 3/5. So we get 48/65 plus negative 15, so minus 15/65. So 33/65. And then on the very last one, which gives us a tangent, for some reason I didn't put the tangent formulas on the front, so we will add those. They're also going to be on this review sheet, so let me give you these. Tangent of, and I'm going to give you we'll talk more about this when you receive the the formula sheet. I'm going to give you the tangent addition version and subtraction version in the same one equation. So plus minus is the sign that they use. So it's tan alpha plus or minus tan of beta over 1 minus plus tan alpha tan beta. So the formula goes, if it's alpha plus beta, then you use the top sign everywhere. So you'd use a plus on the numerator and a minus on the denominator. If it's alpha minus beta to get started, you'd use a minus on the numerator and a plus on the denominator. So that's how that kind of plus minus minus plus works. So we're here to verify, and it is a subtraction alpha minus beta case. So I'm going to apply this formula to the left-hand side. So that's going to be the tangent of x. And again, we're doing minus, minus. So we're taking the bottom side, minus pi over 4 over 1 plus tan x tan pi over 4. That's my left side, which I'm going to stick with for a minute. Oh yeah, I'm just doing this and heading out, so I'll be correct. So I'll be here tomorrow. Yeah. Thank you. I know. Thank you. So if we go to simplify this, tan of pi over 4 is just 1. Tan of pi over 4 is just 1. So tan of x minus 1 over 1 plus tangent of x times 1 just as tangent of x. And then we're pretty much there. I mean, addition is commutative on the bottom, so if you want it to look exactly the same, which we should, we're just going to use the commutative property of addition to switch that around. And then without touching the right-hand side, it's a match. So technically there are 6 formulas. The 2 tangent ones, and then the 2 sine and the 2 cosine from the front. And your homework is here at the bottom. Again, you can get started if whoever's here wants to project the book. You can come up and take pictures of the additional textbooks I have, but you should have about 20 minutes to get started on that. And also, again, with that, remind, if you come across a question from last night's homework or tonight's homework, definitely send me a message and I will do it and send you back a solution.